Hey, I'm Tim. If you're watching this video, you've either already signed up or you're interested in signing up for our 6-week AI LLM bootcamp for senior engineers. Now, in this bootcamp, we are going to be exploring how to build AI solutions for a lot of different problems. You have the classic problems like building a AI customer support chatbot, which is a really classic example these days. You have other front-end facing things like, for example, you could build a TA, a teaching assistant bot for students for a specialized course. You could build more back-end systems that don't have any human interaction or very limited human interaction. For example, let's say that you have a service that monitors for code updates, reviews it for cybersecurity vulnerabilities, and perhaps updates, or flags issues if it spots anything. So what these apps and these solutions have in common is they have very similar architectural paradigms that we're going to be exploring through the 6 weeks. For instance, of course, all of them will need prompt engineering. And you've already been doing prompt engineering at some level, but this is maybe more and more sophisticated prompt engineering techniques. All of these solutions will generally need you to retrieve or fetch or load in additional context in order for it to do its job. For example, if you're a customer support bot, a customer is asking you a question, you need to be able to search through your protocols or the customer record and then load that information in to feed into the LLM. So that process is called RAG, Retrieval Augmented Generation. You'll need to fine tune in general. So for example, you'll start with a general purpose LLM, and that will probably perform pretty well, but then you'll find that it's not going to be 100% compliant in a lot of cases. And so to achieve that final tier of fidelity, you'll need to fine tune. You'll want your LLM solution to be able to talk to the outside world. So we've already fetched, but you'll also want it to be able to write to APIs. You'll want it to be able to take actions. And so those frameworks are called tools and agents. Evaluation is a big part of AI solutions because it is so free form in general. And so in order to think about how to evaluate AI systems is a lot different from a traditional software solution because you need to try to encompass what the normal behavior your AI solution will see. And then you'll find that the way that AI solutions, especially as they grow, they're going to start to add a lot of additional pieces. For example, you may use a very low-end but fast and cheap model to do routing, passing into a larger, more sophisticated model for deeper analysis, yet another model to be your functions interface. And so there is typically, as you progress and build and stack on your solutions, progressive complexity in the number of models that you're orchestrating together. So that's going to be the shape of the 6 weeks. We're going to find that there's a lot of similarity in patterns, even as you're building quite different applications, front end or not front end applications. So in this pre-work, which I think will take you a couple hours, but it's fun and it's simple. It's going to warm you up into a lot of, make sure you have all of the tooling set up, and it's going to start to give you a flavor for how some of this stuff works under the hood. So I'll give you a kind of a demo. So we're going to be building in this application this chat interface. So this chat interface already exists. It's called Chainlit. There's a number of these open source solutions that gives you a ChatGPT like thing. So this is not really a front end class or a front end bootcamp. So we'll primarily be focusing on how to build and construct AI solutions under the hood. And so, but we do need a front end piece to be able to interact with it. So we're going to play with this front end aspect. And let me just give you showcase this a little bit. So one of our prompts later on is we'll ask it for some ideas around business apps to build. So this is essentially a right now it's just linking to OpenAI, so it's pretty similar to what you would see on ChatGPT. And so, you can kind of talk to it here. One cool feature is that the vision aspects of these models, especially ChatGPT, are getting increasingly sophisticated. Like, let's take a look at this image right here. So this is a picture of a living room. So I'll feed that over here and say, describe what's in the image. And there's a little bit of a visual glitch here, but so it does a pretty good job of describing some things. It's pretty thorough. So you can ask it questions about it. It clearly has observed correctly a lot of things. It's interesting. It's interpreting this as a mirror. So to me, it actually looks like a window, not a mirror. So we can ask it about that. It's called out the pillows, the plants. I noticed this book is interesting because it kind of has some holes in it. So let me just ask it about that. So in the coffee table, you can see that it does see that. So I'll say, do you see anything unusual about the book on the coffee table? And you can kind of see that it has observed that there's these circular holes punched in. Are you sure that's a mirror? Let's see if it can kind of figure out. So it's realized that it's not a mirror, which is kind of interesting, right? So very cool, very sophisticated. This is kind of hot off the press in terms of what vision models are able to do. So this is another interesting feature of one of the things that you'll want to do in AI solutions is you want to figure out how to input a lot of things into it, right? Because a lot of our stuff is on Google Docs or Confluence or on the internet, and models are not that useful if you can't feed data effectively into it. So one of the things that you'll need to do is one of your data sources will probably be PDFs, and PDF parsing is still a really complex thing. So if the PDF is mostly text, then there are solutions for that. But when you have complex tables or diagrams, or maybe a PDF that's a scanned image and not typed text, then it gets more complicated. So this is from an article called "Attention is All You Need," which is a seminal article that introduced the transformer architecture in this space, which we'll learn a lot about a little bit later on. So let's try feeding this in, and we'll ask it some questions about it. So let's say here, can you explain the diagram in this image? So we can go into detailed questions about it, and let's try to quiz it on like little aspects of things. So let's just quiz. Let's say section 3.2.1, which is scaled dot product attention. Let's say, what is section 3.2.1 about? So does it say scale dot product attention? Let's see. Okay, so it has correctly identified this thing. Okay, so by the end of this pre-work, the first thing that we'll want to do is we'll want to slowly work through small milestones to essentially build this product. And then this is back using OpenAI. So what we'll also want to do is in this pre-work, you'll switch to connecting it to a model that you've hosted, and it will show you how to cloud GPU host another model. We'll use a very popular model called Mistral. Okay, so that's the target. That's what our goal is. Now let's walk through it. I'll mostly let you follow the milestones, but I'm kind of skim through it and discuss some like small points that are interesting. So go ahead and dig into milestone 1. The first step is to install Python if you're not a Python developer, right? So this is if your operating system might ship with a default version of Python, but you'll want to install Python 3 if you're not an everyday Python developer. So probably about maybe a third of you are Python developers, so a third of you will already be able to be familiar with this. So once you have Python installed, you're going to create this Chainlit application. Now, Chainlit is an open source project, and it's a Python library. So I'm not going to do all of the steps here, but I will walk through some just to illustrate some aspects. So the first thing that you do when you create any Python project is you manually create the thing. So for I'm just call this my app instead of Chainlit demo. So this name is arbitrary. You can call it whatever you want. It's just your project folder. So then you create your project folder and then you change into it. Now, this is new for people who have not done Python before. Python has something called virtual environments, which I'll explain in a second. But first, I'm just going to create it. So this creates, it's going to use a built-in module called venv, virtual environment. So this says, hey, use this built-in module called venv and create a virtual environment called .venv. So what a virtual environment is, you can read about it more in this link, but coming from other systems, it's basically your bundler, your NPM, your Gradle. So it's part of how you work with dependencies in Python. So the way you actually install dependencies in Python is you say pip install and then whatever. So whatever your project needs, you type pip install, just as you might type npm install or bundler install. Now, if I type pip install right now, and then I type chainlit, for example, don't press enter here. But if I type this, then it's going to install it globally. I don't really want that, because other projects might be using different versions of Chainlit or different versions of other dependencies. So what you do in Python is every time, you have to do this every single time you open up your shell, you have to activate your virtual environment. So you type this command. You can kind of see that it changes the terminal to indicate that it's activated. And so what that did is actually a pretty simple thing. It does it modifies your path. So if I say which pip, you can see that it's reaching into your local folder. So when I created the virtual environment, if I type ls-a right here, it's going to create a hidden folder called .vm, because that's what I named it. And then in that folder, it's going to have a structure where it's going to copy every single dependency that I'm installing. So now, once I activate the virtual environment, when I type pip install chainlit, then it's going to copy Chainlit into the .vm folder, and it's going to make sure that my path is set up such that I'm accessing it, any binary files directly from that local environment. So a little bit has some similarities with the way that bundler and npm work, but there's also some differences in its style. So every time you come in, though, that's what you have to remember, that hey, I'm in Python now, I have to activate before I start a project. Okay, so now I installed Chainlit, and then if you notice here, right, I've installed it, but there's no files here, and if I check this project in, and then someone else checks it out, they have no idea which things I've installed. So we want to do what's equivalent to having a bundler file or a npm file or a Gradle file, which is you need to have some file that lists your dependencies. So every time you install something new, you can re-export all of the libraries that you're using into a requirements.txt file. So now if I ls here, there's requirements.txt, and then people who are now cloning my project, they can install my requirements.txt to figure out what they need in order to run my project successfully. So that was a very quick overview. You can read more about it there. I won't do all of these steps here. You should add your git ignore for Python to make sure that it ignores, for example, that .vm folder. You don't want to push that in. That has a lot of binaries. It's very large. You wouldn't want to push that to GitHub. So next is, again, if you're new to Python, I really recommend that you use VS Code. I'm using Cursor here. Cursor is just a wrapper around VS Code. But what I'm going to do is I'll open a new folder. So I'm going to open up my app that I've just created, and I'll see that there's just my hidden folder with my virtual environment and then my requirements. And the cool thing about Visual Studio Code that's kind of nice is if I click this icon right here, which opens up my terminal. So let me close the ports area, I don't need it. You see how this icon is here? So VS Code will automatically activates my environment. So now if I type things in here, it's automatically set up to do that. So it's kind of nice. You maybe don't need to remember to activate your environment each time. Okay, so Chainlit is a very simple framework, and you can read more about it, but one of the reasons I chose it is because of how simple it is to set up. So in order to have a Chainlit app, you actually only need one file. You can call app.py as an arbitrary name, and you just need one function here. So this function on message is an arbitrary name, but this is a special decorator that says, hey, this is the handler that I want to be called every time my assistant runs. So let me shut down my other assistant. And then I'll come back here and I will say, now that I've copied this in, what it's doing here is it's receiving this message every time a user sends a message, and then I'm just going to echo the message back to them. So if I run the app using this command, I'll run it in my terminal here, then it will open up, this thing, and if I say hello here, it just echoes back, right? So that's all it took to get this UI up and running. Pretty simple. If you're new to Python, I'm going to expect you to kind of pick up Python on your own. There's a lot of great Python cheat sheets for senior developers, so quickly translates from Java, and of course ChatGPT now, it will quickly explain to you different aspects of it. One thing to note is this await syntax, which is something you're probably familiar with if you're familiar with JavaScript, but this is the same way that you do asynchronous programming in Python. So it's async await. And basically for any long running function, so this is an interrupt handler, which means it has to run fast. If you take time in here, then it's going to block the UI, and so this is going to cease becoming interactive. So for example, if I make a network call in here, and if I'm just waiting, and if it's a 5-second network call, if I block this interrupt handler, then the user won't be able to interact with this until it's done. So that's not good. So if you have something long running, then you can say something like await, and I'm just going to make up get network, whatever, right? So this is a made up function. And so what this does is when I call await here, even though this is a long running thing, it will actually go and take a nap and block until this is ready. And then when it comes back, then it'll fill response with my response, and I can continue. So that's kind of nice because I can pretend like I'm doing synchronous programming. So I don't need to have any callback spaghetti, but it won't block the UI. So anyway, I'll let you read more details about that on your own. It's Python async await is the syntax. But that's it for milestone 1. Milestone 1, once you commit to GitHub, you'll be up and running. You'll have your Python set up. Maybe you'll have done some background reading on Python virtual environments, and you'll be ready to do some fun stuff, which is to wire up OpenAI. Now, of course, we want to actually have a chat with it. So I'm not going to type everything here, but basically go to your OpenAI. This is, even though you might be paying for ChatGPT, that's different from the OpenAI platform. So you might need to set up your account separately for the platform. Then go ahead and fuel it with about $10. This will last you a long time. You're not going to pass in that many tokens, especially for testing. So that should do you for a while. And then you'll need an API key. So go ahead and follow the steps there, to do that. And then this is another Python pattern. similar to most other languages, you don't want to embed your secret keys inside of your project and check them into GitHub. And so instead, what you'll do is you'll create a .env file, and then you'll put things like this in here. So there's no quotations here. You'll just have your text in here, and you'll paste it there. And then when you get to your app, so you can just copy this. You can just copy this in. So just replace maybe what's here. And let's take a look at what's different. So the first thing you do is fetch your OpenAI key from the env. And then, we'll create an OpenAI client. Now, even though this is called an OpenAI client, one of the convenient things that people have done, not every model has done this, but many people who are providing these open source models, there are typically layers that people have created such that when you interact with them via HTTP, they've standardized on the OpenAI API spec so that you can use the same client. So even though this is called the OpenAI client, it will work for any backend that is using an OpenAI compatible API. So that's kind of handy. So we'll be able to do that. This is a Python-ism that you can look up, keyword args. So what it does is it's just a pattern for you to jam a dictionary and combine two dictionaries together in a concise way if that's what you need to do. So we have our configurations here. Then we go and we get the chat response from OpenAI, and then we pluck it out of the format. You can read more about the format in this link, and then we send it back to the user. So once you've done that, you should be able to chat back and forth, with your working chatbot now. So I'll let you pause. I'll let you pause the video and catch up to that point. Okay, so hopefully you're resuming now. You've completed milestone 2, and I want to introduce you to an idea, which is one, you should start thinking about and researching what app that you want to build in the 6-week bootcamp. You can either build it as a solo project or you can build it as a group project. So we're going to let you choose whether you want to be solo or in a group. But the first thing that I want you to explore is, hey, this is really a lot like ChatGPT, except we have a new feature, which is we can adjust the temperature. If you haven't played with that yet, temperature, if you're close to 0 in temperature, then you're going to be very reliable statistically in what you generate, but very boring maybe, and with the least amount of variation. And then if you try temperatures of like 1 or 1.5, you'll get increasingly creative, but maybe increasingly nonsensical too. So you can kind of play with that temperature threshold. So as a first fun thing to do, literally paste this prompt in, try, a boring prompt, other prompt. You can also ask it to generate poems and see if you like poems, for lower temperatures versus higher temperatures, or how you feel about that. But this is a fairly open-ended prompt, so you might be able to see some variations there in terms of like what it can generate in terms of ideas. All right, so moving on to milestone 3. So you'll notice a couple things that you probably didn't like in milestone 2, which is I think most people don't realize that LLMs are completely stateless, right? So when you have a chat history here, if right now the way your assistant works is, it's actually just working with the last message that you sent. It has no memory of your previous history. You can test it by telling it your name and then later asking what your name is, then it will have no idea, right? So that's the default nature of LLMs. Now ChatGPT and LangChain and other systems, what they do is they actually, believe it or not, with every single message you pass in, they aggregate the entire chat history that you've had so far with each message. And the second thing they do to make things like seem faster is that they, the way that the model works, the LLM model works, is actually tokens will become available, character by character. So one thing that can make the system feel more responsive is to stream it instead of waiting for the whole thing to be finished as we are currently doing. So those are the two goals for this milestone, which is to convert to streaming and then also to add in the history. So I won't type this in because this is fairly straightforward. I just wanted you to see the before and after of what this looks like. This is what streaming looks like versus what it looked like when you're waiting for the whole response. So this is, again, ask ChatGPT or something, to explore this syntax, but that's how the streaming works. Update is just the signal to Chainlit that I'm done typing, and you can kind of consider this message finished. In fact, you can remove this and see what the effect of that is. You'll see that it thinks it's still like a pending message. And then we'll create chat history. So this is pretty straightforward. What we'll do is we're going to leverage a pretty standard web pattern where Chainlit actually provides a persistent, in-memory dictionary. And so I can go and fetch and store arbitrary keys into that dictionary. So in this case, I'm going to keep a piece of data called message history, an array of messages, and I'll just stack the message history. So for example, here, the user's incoming messages coming in, and then I'll store it this way. So you might be wondering, hey, what's up with this pattern here? I have the role user and then the content, and then check this out later, role assistant and content. And actually there's another role called system. So what's all that about? So that is a chat template format that OpenAI understands. And so in this chat thing, it's expecting an array of dictionaries where each dictionary is a message and then has the role and the content in its store like this. So this is an expectation of the OpenAI training. Now, we're going to understand later as we're doing fine-tuning and training that all models, they perform better with training when you have very structured conversations. And so, we'll look at different ways that to structure that and prepare that for training data. But for now, this is something that a lot of people use because this is kind of what OpenAI uses. And so this is the convention here. I think it'll reject it if you don't follow this convention. So it's quite strict. It's quite strict with it. But by doing this, this now adds history in. So I'll let you pause here to catch up. But once you reach this point, you should be able to have streaming conversations with your AI, and then also it'll remember your history. Now for this milestone, there's another video which will be linked in this document, but it's pretty cool. We're gonna transfer off of OpenAI, and we're gonna host your own LLM model. And so in order to do that, you'll switch to the other video that runs through that process. But before I sign off for this video, I just want to do the last fun element, which is supporting image attachments. Now, most models don't support images. So only some open source models support images, and then GPT 4.0 and 4.0 mini also supports images like we did. So it's pretty straightforward to do. In this snippet, what you have to do is you have to pluck the image out of the message.elements, and then you have to base 64 encode the image data, and then you actually embed it into the message history. So it works pretty well as you saw. Now, the only gotcha that I explained over here is that it's actually every time I'm chatting with this assistant, and if I pass an image in my history, it's going to take that image and it's going to send it each time. So that's obviously not the best. So, but as you can tell, I mean, it wasn't terrible either. I mean, the network speeds were pretty fast. So, however, you might want to consider for a more production app, first uploading the image to some bucket somewhere, and then when you pass the URL to GPT 4.0, it will cache the tokenization of that image on their side of things. So it'll be even faster, right? So with that, I mean, that is all it takes to get up and running. And so, you should be familiar with a little bit more with Python and the basics of like Python development environments now, getting a sense for like how to interact via HTTP with LLM models, which will be the most common interaction, right? Like, so that's how you'll typically work with models, is via an HTTP kind of protocol. And next and finally is just to submit your repo. So when you're finished with everything, then go ahead and fill this form out to submit your project, and then we'll be ready to hit the ground running for the first session. It is required, this pre-work is required before you hit the first session, because the first session does have a lab in it, and you're not going to be able to do the lab successfully if you have not yet completed this pre-work. Cool, have fun, and hope to see you on the first day of class.